the truth is that machine learning is being influential beyond its own applications, and it's not that in science we have machine learning being applied in many other areas, and in cooperation or working together with some other more classical statistical approaches. And then there's this emergence of this new area with a new discipline or rebranding called data science, and which can be seen as, I think you said the science of data, or maybe it's just applied to machine learning and statistics applied to science, but there are different perspectives of what data science is. You have been promoting associations and of course doing research in data science. So how does data science relate to machine learning in the first place, and also with artificial intelligence, which also has some other things such as planning and some other things that perhaps are not that data intensive?
Mm-hmm. Yeah, that's a great question, and I almost I wish we had now a whiteboard and I could kind of draw a Venn diagram, because of course that's the kind of thing that you get now. So if the viewer imagines a Venn diagram with three ellipses, which are machine learning, data science, and artificial intelligence, and there are things that are in the overlap, and there are things that are in the the symmetric difference that are, for example, in AI but not in machine learning. So we talked about reasoning earlier, and that's kind of there, or planning. With data science, it's interesting because some of this is terminology. Terminology is not the most interesting topic for me, but we need to agree about what terms mean. There are statisticians who say, well, statistics is the science of data, so the data science is just a different word for statistics. I think it's a little bit more interesting than that, because I think statistics traditionally doesn't have a very strong computational angle. I mean, in fact, computers 100 years ago were people, in fact, often women, because they were better at doing the computations on paper than men. So that was the human computer. So now we have algorithms. Some algorithms are more efficient than others, and computer scientists understand that. So I think data science is statistics plus some kind of computational literacy, I think. When it comes to machine learning, it's very popular in machine learning to set challenges. Here's a data set, this is what we're trying to achieve, now find the best model that achieves that. The Kaggle platform and other platforms have that. So that's in a sense, a very abstract setting, because if you have a Kaggle competition, you get a file with data which is already kind of quite clean data in comma-separated values or what have you. And you were given an objective that this is what we're trying to achieve, mean squared error, minimize mean squared error or so. And that's kind of a very that the real world doesn't work like that. There are no CSV files in the real world. There is not even, in a way, data in the world. There are things and objects and things happening which we turn into data. Also, there isn't a clear objective function that, for example, a company or an organization like the NHS tries to optimize. It's much more complicated than that. We have some intuitive understanding about what we're trying to achieve. So the NHS in Great Britain tries to make people more healthy and cure them. And of course you can derive metrics to measure that, but it's not the metric which is the goal, it's something else that is the goal. So data science deals with that whole world. So I sometimes explain it to my students and say, data science is the stuff that you need to do in order to make something into a Kaggle competition. So you need to collect the data, you need to pre-process it, you need to put it in an Excel spreadsheet or so. You need to think about what is the objective function. And then the machine learning can happen. So I think data science takes a kind of more realistic view of the place of machine learning in the world and how it can be made useful. And of course, researchers in other disciplines now often use those techniques as well. They are data scientists in a way. So if I look at the University of Bristol, there's virtually no discipline that doesn't deal with data at all. History, of course, by definition deals with data, but they don't think of it that way. They think of it in terms of narrative and events, but you know, there is data there. There is data everywhere. So data science is also part of data science. It's about teaching people how to do that, because we know about the data. We know about what, you know, the technical methods of data science. We don't necessarily know about what data you have. So that will be some kind of collaborative action where I need to understand about your domain, be it history or epidemiology or so, and you need to understand about the techniques that we've developed. And so it's by definition very interdisciplinary, which I think is a good thing, but it's also not easy, because, you know, research everybody tries to find their own little niche, and we humans find separation always easier than bringing things back together. So it's not an easy research agenda, but it's important.
So even if it's data science, it's a lot of engineering going on. Even data engineering usually refers to a sub part of data science, but it's very engineering focused, even more than machine learning, which is in a way more abstract. Even it has a lot of application. Data science is more about solving problems, about real data.
Yes, but let me be clear. I mean, I don't view engineering as a kind of inferior to science. And you know, engineers, there are good and bad engineers, and there are good and bad scientists. But you're right, engineers tend to be more problem-driven. Also, they don't have an empirical method. You know, engineers building bridges, they don't try different ways of building bridges and then see which ones fall down and which ones don't. That's not how we want to do engineering. We want to be reasonably certain before we build it that we're actually building the right thing. So it's a different discipline in that respect, and I think computer science combines the two things. So there are aspects of computer science that are more mathematical oriented and therefore more closer to science, and there are aspects that are more closer to engineering and sort of, you know, evaluating things empirically, which makes it for me so fascinating. So it's an incredibly rich field, and same for AI. AI touches every other field, and that makes it interesting. If I want to work on AI for music, I can do that, or AI for epidemiology, or trying to understand pandemics or so. It's not a huge change for me, because at the core are the same methods.